We're now going to be moving into molecular structure. Up to this point, we've really been focusing on the elements and atoms. And even when we think about the compounds we created with these elements, we're really dealing with an atom charge, a cation combining with an anion. And we're really still sticking with the atomic structure with everything we've talked to. As we move into molecules, we're actually going to be looking at a much more robust and a much more complex system. In molecules, we're not talking about taking a positively charged ion and a negatively charged ion. What we're talking about is actually combining those atomic structures into a new molecular orbital system, a true sharing, partnership of the elements in the molecule. When we looked at atomic structure, if I lost an electron, that became a cation. It would be electrostatically attracted to an anion, an element that gained an electron. So if we think about sodium chloride, sodium wants to have a positive charge. It loses an electron and has a full octet by going back to the next noble gas configuration. With chlorine, we actually add an electron, again to go to the noble gas configuration. Those two then electrostatically combine. This is usually referred to as an ionic bond, but really it's just an electrostatic attraction. When we think about molecule, and the molecule that we most often refer to is water. In that case, the oxygen and the two hydrogens combine their electrons and modify their orbital structure into a molecular orbital structure. It's not an electrostatic charge, but it's actually a true sharing through a covalent bond of the electrons. This is a paradigm shift in how we've been looking at compounds. Ionic bonds are those bonds made between a cation and an anion. If I had sodium Bob and sodium George, and I have chlorine Mary and chlorine Sue, it turns out in an ionic structure, Bob could be with Sue, George could be with Mary, George would be with Sue, Bob could be with Mary. But when we talk about a molecule, and we're thinking about covalent bonds, this is a pure sharing of electrons. So therefore, the hydrogens that are attached to oxygen and water are going to be attached to oxygen and water. We're not going to have any dispersion. In this unit, we're going to be talking about molecules, molecular structure, and we're going to be talking about bonding. Ionic bonding, covalent. In covalent, we actually have two levels, sigma and pi. Anytime we have a single bond, that's going to be a sigma covalent bond. Anytime we have a double or triple bond, that second or third bond is going to be a pi bond. The other features that we're going to need to learn in this unit are Lewis structures, resonance structures, and geometric structures. Lewis structures give us a way to talk about where the electrons are in compounds and molecules. Resonance structures are snapshots. They're a way for us to communicate where electrons are in a molecule at a time and space. By taking several resonance structures, we can get a better view of the overall cloud of electrons in that molecule and what the molecule really looks like. The geometric structure, from how many covalent bonds we have to a central atom, we can predict the actual shape in 3 dimensions of that molecule. Like many things in this course, this is something we're going to come back to again and again. It sets up a foundation for our understanding. Molecule understanding is important as we move into organic chemistry, biochemistry, molecular biology. Make sure that you take the time to get a firm foundation in molecular structure and bonding.